Okay, we've looked at several different ways to forecast the future. Um, you might ask yourself, well, why do we have to learn all these different ways? Why not just use the best way? And the answer to that is there is no best way. Some methods are best under some circumstances, and other methods are best under other circumstances. Um, so we need to be able to test them. Now, remember that what we're doing is we're predicting the future. That's what a forecast is, and no one knows for sure what's going to happen in the future. So, sometimes a forecast works pretty well, and sometimes it doesn't work as well. But we don't really have any choice. We need to forecast because we need to make plans for the future based on what we think is going to happen. Anyway, in terms of a forecast, the best forecast is the one that gets the best results. And what are the best results? Well, for instance, if I look here at the naive method and I see that in period 1, I made a forecast for period 2 of 22, and I actually ended up with a demand of 18. So I wasn't too close. There was an error. So I can make another column here, and I can call this column the error of the forecast. And it's really very simple. All I need to do is I just need to subtract one from the other. So here was my actual, and then here was what I forecast. And so here my error was -4, so the demand was 4 less than I forecast. And I can just copy that down all the way. Like I said, those are my errors. So here I was 4 low, here I was 5 high, 2 low, 4 low, 7 high, etc. Then I could take an average, and that would be the average error, which would be some indication of how accurate my forecast method is. So in this case, it looks like my forecasts are really very close because the average error is just 1/10. -1/10. But I'm sure you can instantly see that the here I'm off -4, here I'm off +5. So one kind of negates the other. That doesn't make the forecast more accurate. What I need to do is I need to get rid of those negatives, and there's a couple different ways of doing that. So one way is I take the absolute value, which is a Excel function called ABS. That's the absolute value, and you probably know that the absolute value of a number uh, just strips out the negatives. Okay, so instead of taking this minus this, I take the absolute value of this minus this. Okay, so that's my formula. Then I can just copy that formula down. All right, so now it shows that on average, my forecast is 3.4 units off. Okay, and we call that MAD, or mean absolute deviation. So basically, a mean absolute deviation is just what's the average error. And let me put this down here. Okay, I'll just cut and copy that. Okay, so that's MAD. Okay, mean absolute deviation. Um, so I'll call this as another way that I can do it is I can use, this is the method your book seems to like, MSE, which is or mean squared error. Okay, so that's another way to get rid of negatives, is to square the number. So instead of taking the absolute number, I take what actually happened. Let me put parentheses around here. I take what actually happened minus what we forecast would happen squared, because any number squared is a positive number. Okay, and then I can take that number and then this would equal the average. So my mean squared error is 15.2. Okay, so what is that? Why do you care? Well, you care because you want to see which one is most accurate. And like I say, your book likes mean squared error, but the 15.2 doesn't really mean anything. It's a big number. The 3.4 for the mean absolute deviation, or MAD, that tells me that I'm 3.4 units off on average. So I'm just going to, now that I've showed you how to do mean squared error, I'm just going to use the mean absolute deviation. Okay. So I'm going to hide all these, I'm going to unhide all these, let me get rid of this. Okay. I'm going to unhide all these columns, and then I'm going to compare them. Okay, so I'm going to insert a column here, and I'm going to do just what I did before. This is MAD, so this equals the absolute difference between this and this. Okay. Okay, so there's my average error for the naive method. Okay. Then I'm going to do the same thing for simple moving average. Now I can only do what I have here. I can't calculate an error for the ones that I didn't make. So this equals the absolute value of what actually happened minus what I forecast would happen. Then I copy them down, and then average. Okay, so we can see, for instance, that in this particular circumstance, using the naive method, I have an average error of 3.4. Using a simple moving average, I have an error of an average error of 2.0. So comparing the two, the simple moving average is more accurate than the naive method. So let's do the same thing with a weighted moving average. That's 2.5, so still the simple moving average is more accurate. Now we'll do exponential smoothing. Well, one thing I should tell you, with a weighted moving average, you could do the same thing with different weights and see which method gave you the best best results, which would mean the lowest mean absolute deviation. Okay, now I'm going to do the same thing here. That gives us 2.1. So, and again, you could, with exponential smoothing, you could make your forecast with a different smoothing constant, a different alpha, and see if you got better results. And finally, we'll do the one with trend here. Same thing, equals the absolute value of this minus this. 1.8. So based on the data we've had of all these examples, the trend forecast, which is basically regression using the passage of time as the independent variable, gives us the smallest average error. And so if it has the smallest average error, it's the most accurate. And we would probably want to use this one going forward. You could also do another one. You could do, now these are all called time series forecasts. You could also forecast the demand based on regression with, say, we want to know what the demand is for washing machines. We might look at the gross domestic product or the Dow Jones average to get an idea of the strength of the economy and use that as an independent variable to forecast demand for the washing machines. And we could do the same thing. We could calculate a mean average deviation for that method might give us something more accurate. But that's basically what we're doing. There's several different ways of forecasting. The naive method is the easiest way. If the naive method gives you the best forecast, then use that one. If multiple regression gives you the best forecast, use that one. If exponential smoothing with alpha of 0.7 gives you the best forecast, use that one. But that's basically how you judge between them and decide which one we're going to use. So I used mean absolute deviation in all these cases. Okay, so this is MAD. And in all cases, the one with the lowest deviation is the best. I could use mean squared error instead, and the numbers wouldn't make as much sense, but still the one that had the smallest mean squared error would be the most accurate. Okay, so if a problem asks you, asks you to forecast something in two or three different ones and then say which one is the best, well, the best is the one with the lowest or the smallest average error. It's the most accurate forecast.